Welcome back, everyone. We are now with Brian. Welcome, Brian. Thank you for being with us.
Hey, Samuel. Good to be here.
So, another guy from Europe. How are things in Netherlands?
In Netherlands, it's quite okay. I mean, the weather is good, so not complaining. It's 28 degrees Celsius over here somewhat. And
28. Are you sure you are in Netherlands?
I'm sure I'm in the Netherlands. I was not sure before, but I just looked outside. I'm still in the same place I used to live. So yes, I am. And well, things are quite okay here. They are just lifting some restrictions, so I'm not complaining.
Okay, so this track actually has been mostly around front-end stuff, JavaScript, TypeScript, and we are now switching back to Java with you. So
Exactly.
without further ado, we'll pass it over to you. Thank you, Brian.
All right, amazing. Thank you. Well, finally, we get back to the good parts, right? Java. That's what this conference is all about. No, I'm just kidding. The first talk this morning was an amazing talk by my coworker, Lily. She did an amazing job, so props to that. But we're going to talk about Java and specifically on security, because let's go to this one. And probably you have seen this one before or you recognize it from a movie. It is actually there in London. I think it's Liverpool Station, but it's a reference to the Harry Potter movies. And you know that Harry Potter needs to be on platform 9 3/4 to catch his train to Hogwarts, right? But if you don't know it's there, you will not find it. Only if you get with the right amount of force, with the right amount of tools, with the right amount of pressure on the right spot, and you hit it, you will turn into that platform 9 3/4. Unfortunately, there's a link with security over here, because in many cases, if we look at programs, we see that these programs are looking perfect. From a functional perspective, they are working, they are doing what they must. We have tests around it. But unfortunately, if you pinch at the right point with the right amount of force and maybe with the right tools, you will get into parts of the system that you don't want people to be. For instance, they see data you're not supposed to leave in the open. They can do other things. So there are some things about security, if you're not aware of it, they are not on your mindset. First of all, this is me. I am Brian. I'm a developer advocate and engineer for Sneak. I'm still working on the Java space mostly, and you see I'm active for some Java user groups like the Virtual Jug and the Utrecht Jug, and we have a special online user group on developer security called My DevSecOps. So if you're interested in that case, please sign up for that. We have a Slack channel, online sessions, the whole shebang. But this is the least important slide of my deck, because we're going to talk about this. Because if I'm going to ask people how important is security or who is responsible for security, more or less the answer is somewhat like this. This is a part of the State of Open Source Security. It's a report from 2019. And you'll see over here that, well, security is more or less a shared thing. And it's shared between a lot of different groups within the development cycle. But everybody says, or at least 81% says, that developers need to take their fair share. So we need to be educated about security. We need to know what security is all about, right? So in this talk, I will lead you through a set of security best practices. And it might be that you are already familiar with all of these. And if in that case, you're on the right track, my friend. You deserve a security badge or a raise or more vacation days or whatever. But if there's one thing or maybe two things you can pick up and you can implement tomorrow, I'm a happy man. So let's go to the first one. And it seems obvious, some of them, but hopefully some of them will not be as obvious as you think. The first one will be SQL. And why SQL? Well, although we do a lot on NoSQL, it's still called a SQL injection. And we're going to talk about SQL injection. And don't be afraid if you say, yeah, but I work with a NoSQL database. Well, in many cases, NoSQL databases have some engine that is similar to, you already guessed it, SQL. So in many cases, NoSQL or SQL injections are also available or can be utilized in NoSQL databases. When we look at the OWASP top 10 vulnerability sheet, the last one was the release in 2017, if I'm not mistaken, you will see that SQL injection is still at the top of the vulnerabilities that will be exploited. So that means even though a lot of people will say boring, it is still something that you need to learn, you need to take, and you need to take into account when you code and when you review code. Because you might be the smart people, you might be the smart person in your team, but you probably work with a junior as well. So teach your people not only to code right, but also code secure. Let's go into SQL injection, and I will do this with an example. You will see my IntelliJ over here. And you will see I have a search function over here, and I have a show all function over here. Well, let me just quickly run this one, and you will see what this demo is all about. This is a very, very short demo, and it contains a database with 5 entries, entry 1 to 5, with 5 familiar superheroes or their nicknames: Clark Kent, Bruce Wayne, Tony Stark, Barry Allen, and Steve Rogers. In the second line over here, I search for Stark because my search query allows me to search for the last name, and it will return me Tony Stark. Cool. But if we look closely at this part of code, you will see that I am using my parameter that I insert, I probably insert from a web view or whatever, directly into my query. And there's the problem, because this code is vulnerable for SQL injection. Because if I'm not like searching for Stark, but doing something like this, I quit the query or I shortcut the query over here, do an OR exception, and say something like this. If I do this, and you will see what happens, and let me just block out that show all for a second and run this, you will see that instead of searching, you will see that I entered the whole database. Because I simply, with this single quote, I quit this part, and I just executed the OR part. But it can be even worse, because if I do this, and instead of that, and do something like update users, what is it, set last name is, well, like make it J Nation, not J Nation. Sometimes typing is kind of hard. If I do it like this, you will see that it doesn't have any feedback, right? Because it doesn't give anything back. But if I do a show all after it, so I do this, and I will give you a show all, you will see that instead of just querying something, I actually was allowed to change the stuff in the database. So by not being aware of this and just having functional tests like, oh, it works, fine, cool, you should be testing all these weird queries like this as well. How can we solve this? If we work with a old-fashioned SQL database, we can solve this by not using a statement, but by using a prepared statement. And a prepared statement is a tool to parameterize your query parameters. So we want to cut down, we want to distinguish the part of the query and the part of the parameters that you insert. And in this case, we want to bind them to the type system. So we know that what's coming in there is not part of the query, but is a string or a long or an integer or whatever. So by doing this, we can simply do something over here. I can refactor my code to an instead of statement. I will do a prepare statement. And instead of create statement, it must be something like, I think it is prepare statement. And let me insert the query. Cool. Now what we have to do is we have to insert that parameter I want to do, right? Because we still want to set something. And in this case, I bind it to the type system. I bind it to a string. So my insert is a string and not part of the query. So I will do it at part 1, and I would say parameter. So now I insert over there, and I can simply execute it. So by doing this, again, I decouple the parameter from the SQL string. And in this case, if I run this again, you will see that basically nothing happened because this one doesn't do anymore. This doesn't do anything anymore. We're not allowed to do SQL injections, and in this case, we're not allowed to do a new SQLs, new queries indeed. So by doing this, you have saved yourself the trouble of going into SQL injection debugging. Again, most people nowadays are using Spring Data. And if you're using the Spring Data interfaces that do a lot of things by default, a lot of this is already done for you. But in many legacy systems, you still have to do it yourself. Just be aware of the fact that if you need to specify your query and you have parameters that you make a separation between them and that you bound your parameter and you check it and you bind it to the type system in this case. So that was the first one. That was easy, right? So let's go to the second one. Then the second one is also not that hard. Actually, if you look at them all, they're not so hard and they're quite easy to implement, depending, of course, on your context. Second one is OpenID Connect and two-factor authentication. Well, why do we need to discuss this? Well, first of all, identity management and access is hard. It is still, again, in that top 10, and you see that field identity management or trying to do identity management yourself, in a lot of times it goes wrong. So the first thing is that, and that's basically the tip for, I think 80% of the Java developers. Do you actually need to do this yourself? And if you're not, then you're on the right spot. If you have to do that because you're in a certain sector that we cannot leave this to another party, you still might reconsider because, well, we're also using cloud vendors, right? But let's go into OpenID C or OpenID Connect. What we're trying to do with OpenID Connect, we're trying to bind OpenID Connect or an OpenID profile to your system. So basically, we want to not do it ourselves, but leave it up to things like Google or LinkedIn or Twitter to use their authentication process, or even other third parties, to help you out by doing this. Because they have strong passwords, so you do not have to manage that. They have all sorts of things in place that their authentication is already there. In the early days, we used to do things like if you need to import something in LinkedIn or whatever, they will call out and ask you to input your password so they can actually access them themselves. Now that's not necessary anymore. With the use of the token, it's built up on top of OAuth 2. We can simply do it without sharing the vulnerable stuff that is only specifically to you. So basically what I want to say is try not to do identification yourself. And it's quite easy. Most of us will probably are using Spring Boot for our applications. And I did it over here. This is a part of my Spring Boot YAML, and everybody loves YAML, right? And what I do here is I do my Spring Security OAuth 2 registration with both GitHub in this case and with Okta. And I can choose, I can do both, I can do 2, I can do 3, whatever. And with multiple clients, you can log in and they will do the authentication for you. And they will give you information on what the user is and what their rights might be and who the user is, what's their username, etc., etc. Why I inserted Okta is because Okta is a provider, in my opinion, a very good one to use, or a very good one to use for this application. What you can do with them is you can manage everything yourself. If you're not comfortable by doing it by Google or by LinkedIn or whatever, you can use them. You can create an account. You can create a free dev account, if I'm not mistaken, and you can do it over there. But most importantly, they also provide you stuff to do two-factor authentication. And two-factor authentication is basically this. It's something you know, so your username and password, so you need to log in. And it's something you verified with, something you have. In this case, your phone. So you log in and you get a text message on your phone, or you use an authentication app that gives you a code back. That means that you're not vulnerable to password attacks anymore, or not so much. Because there are multiple factors available, and two-factor is, well, it says 2. You've got multi-factor authentication that consists of more than 2, or can be consisting of more than 2, like iris scan, fingerprint, whatever, name it. But it's something, two-factor is something you know and something you have. So you do not need to re-enter your password every 3 months anymore, but you ensure that safety as well. Try to use it in your apps by using a third party. That's my advice on that. Unless you need to implement it yourself, then think about how you do that, because that's a hard one and you probably need some expertise on that. Next one, dependencies. Well, dependencies is an interesting one because this is the part where my company most of the time comes in. Because if you look at an application, say this is your application. If we look at the part that is actually your code of the binary that goes into production, it's probably something like this. Because we depend on frameworks, libraries, and that library depends on libraries, on other libraries, and on even more libraries. So the whole jar you put into production is far more than your own code, which is fair because we do not want to be working on, yet again, boilerplate code, right? So I have a small example over here. It's a 222 lines of code application for a Spring Serverless example. And it had 5 direct dependencies. These direct dependencies have dependencies, and they have more dependencies. And in total, I bring in 54 jars, 54 dependencies, including the direct ones. The thing I want to say is that 222 lines can come up to a massive amount of lines of code. If I decompile everything and I count the amount of lines at that point that we did this test, it's almost 500,000 lines of code. And think about it. You probably review your teammates' code, but how are you reviewing dependencies over time? Do you do that only when they come in? Do you actually do that? Or how do you take care of that? Because the majority is not yours. And if we look at open source, say it's an Apache library or a Spring library or a whatever library, doesn't matter. If there is a vulnerability found in such a library, chances are that a lot of people, a lot of applications are vulnerable because it's so well used, you can just try that hack on simply every endpoint on the internet, right? Well, demo. Let me go to this example. It's a small Spring Boot example that gives you a grocery list. Beans, milk, bread, sausage, and beer, and it has a price. Nothing important. So the item itself is not important because it's an ID, a name, and a cost. The important part is here. It is the REST template. And I'm using Spring Data REST over here. And as people may know that if you use the CRUD repository in Spring, you only have to provide the names. And by convenience, it already implements the queries for you. That is a lot of convenience. It's amazing. But with this annotation, the repository REST resource, it also creates a REST endpoint for the same CRUD repos. So let me just try to run this for a second. And hopefully, because I always have to pray to the demo gods, this one will work. And in the meantime, I will open my browser so I can show you what actually happens. Right? One second, I have a new window over here, and I will go to localhost 8080, and it will redirect me to my hell browser, which is cool. Let me just make it a little bit smaller, and I can do something like this. Say item/1. If I look over here, it will give me my first item on my grocery list, like beans, and well, I can do the second, third, etc. But I can also do the search things like the find by name I just showed you, which was only a CRUD repo, and I can search for beers, and it will give me back my beer for $5.99. Amazing. But let me get into something different, because I hope you can all see it, but I'm doing a command line curl patch request over here. Because the library over here, this old, out-of-date Spring Data REST library has an issue. And with a patch library, with the patch request, I can insert somebody, which is basically JSON. If I do a patch request, for some reason, I am allowed to access the Spring expression language. And what I do in this time, I will just try to spin up a new runtime and give it this command, env. Basically, give me the environment variables of this machine. And I run it on this endpoint that was there just to give me the first item of my list. Nothing more, nothing less. And if I run it, you will see that I have the environment variables of my local machine over here. So by just using that library and not knowing that it has a problem, you'll see that you might be vulnerable if you're not aware of it, right? And you can basically easily do this by doing a sneak test. I did it over here in the command line just to save some time. This is the output for this thing. And what you can see here, it says issue to fix by upgrading. Well, I'm just using my own tool, but there are a lot of tools you can use over here. But you need to scan for these problems. And for instance, it says like, if I use this or use 210 release instead of 155 build snapshot, yeah, who uses a build snapshot, of course, I will get rid of all these issues. And if I use Spring Starter Data REST 155 build snapshot and replace that for at least 159 release, I will get rid of this arbitrary code execution I just showed you and a bunch of other vulnerabilities. Point is that you need to have tools in place that help you find these vulnerabilities. Snyk can do that, and there's a lot of others. Everything I showed you here, you can use for free. And let's go on to the next one. All right. Sensitive data. Sensitive data is always an interesting one because you probably have heard of the least privilege principle, right? And the least privilege principle is, well, it's somewhat logical, but in many cases, not really good implemented. If we look at the least privilege principle, it basically says you only get access to what you need to do your job. Not more, not less, because less you can do your job. More, it's not needed, right? Just get with that. If I'm in the hospital, I don't want that every hospital employee is allowed or able to see my medical file because it's simply none of their business. Only the doctor that's treating me needs to see that. And on top of that, that doctor does not need to see what my yearly income is and that I have a wife and a girlfriend, for instance. This is not true. My wife is watching. No, it's not. But you get what I'm saying? It's none of their business. So least privilege principle is something you need to take care of when you are working with client data. And of course, a small demo, and it is an easy one how you can solve these kind of things. So let me see which one I need to use. Oh yeah, first of all, I need to cancel the other one or else we have a clash. Let me stop this one because I need to spin up another Spring Boot application. And what this Spring Boot application does, it will give me, again, a number, or it has a simple database of, well, in this case, 3 people, 3 names, Clark Kent, Bruce Wayne, and Tony Stark. And as you can see here, they are in my database. And this application has an endpoint, users. Well, let me try that. So if I go back to my browser, and again, I will go to localhost 8080, because that is where my stuff is. Oh. You will see that Clark Kent, the address is there, and the ID. But now we have to think like this is directly my domain entity user, which contains an ID, a first name, a last name, and an address. Do I actually need to expose all these things in my endpoint? Because maybe I need it for the front end or something, and maybe only the name, the first name, and the last names are needed to display, and not the address and not the ID. If you do that, if you display too much, you're simply leaking data. And people will try this endpoint out because it's quite easy to find out which endpoints you're using, and people will try this manually and see that, well, you're now not only giving the last name, you're also giving the address, and you have a PII incident, or basically a GDPR incident. Well, we all know in Europe what GDPR is. It's about data privacy, and etc. But then we can track it to a specific person, a specific location. It's way too much to just expose, right? So say in this case, we want to make sure that only the first and the last name are displayed and not the address, although it needs to be part of my domain. Well, I have my domain entity over here, and the domain entity is basically what I want to show. I don't need it for anything else. And by simply doing something like a JSON ignore over here, it will make sure that JSON parser will make sure that it doesn't take this part into account when marshalling and unmarshalling the stuff, or in this case, marshalling it to JSON. I'm sorry. So by doing this and rerunning this, yes, I want to rerun this. and this might be in your opinion, a silly thing, but I was actually in an incident where we showed way too much information on an endpoint, like in the early days. By doing that, the fix was just add JSON ignore. So it was fixed within 2 minutes, but the aftermath of explaining why this specific token or whatever it was exposed in the outside world was a big hassle, right? So now I know that if I'm going back to my application and I rerun this, you will see that I only have my first and my last name, which is enough for my front end. What we do see is that in the logs over here, it still prints the whole stuff, the whole shebang. And, well, the ID might be interesting for an administrator, but is an administrator allowed to see the address? Maybe it does, maybe it doesn't. But say it doesn't. Well, then we have to rewrite, for instance, the string method or the logger or whatever. Well, in this case, I'm using Lombok because I'm lazy. And I personally like Lombok, but let's not get into a discussion on that because, well, it's very opinionated. But I can do something like toString.exclude, and I make sure that the address is not anymore available in the toString method. And by doing this, I am sure that it's not available and the address is not available anymore to my administrator who needs to see the logs and maybe needs to see the IDs. And the output to the outside world is also deducted to only the stuff that you need. So basically what I want to say over here is with the tooling that you have in place, you might have already a lot of stuff that you can exclude stuff in your exposure to the outside world. Data is important. So you have to have architecture on that, on how to expose that data. And also look at it if somebody is just exposing a domain entity, if that's actually necessary. Maybe you need a layer in between, or maybe you just have to deduct the amount of data you want to show to the outside world. Just be careful on that and use that in, for instance, code reviews. So you see over here that now it's only for the, it's only printing out the ID, the first name, and the last name. All right. Slides. Input. Well, I'm from a functional programming background. So we say input needs to be done in a monad. Let's not go there, right? But input is something that is both dangerous and inevitable, necessary. Because if we cannot get user input, what do we want to do with the program, right? But users can do a lot of crap. Maybe not manually, or manually they can do it, but if they can automate things, they will do a lot of things to try to hack your system. Like giving you input that might lead to cross-site scripting. XSS. Basically, cross-site scripting is we are inserting some script tag or some script file or some script input, and we try to execute that on a remote machine. So basically, if it's on the front end, the remote machine of the next one who is executing that page or rendering that page. If we look at the OWASP rule set and we see rule 0 for preventing XSS, it's basically saying never insert untrusted data except in allowed locations. So that's a good one to remember. It's very straightforward, it looks like, right? But just deduct the amount of places where people can actually insert things and are free to insert things. Maybe you can deduct it to just a button, that it's just only pre-programmed stuff. But if it's a free range form or that it's something that if it's actually necessary, then you need to do it. But just allow it over there and not more. It can be convenient because testing, I know, but from a security point of view, narrow it down to the least part. And for that part that needs to be there, where you need to have that insert field or whatever, make sure you sanitize it. Because every input must be considered harmful. If you consider every input harmful, you're basically on the good path. You have to sanitize everything. Every input can potentially be harmful, so we have to do something about it. But how can we sanitize stuff? Well, it can be quite easy in Java because there are a few things available. For instance, if I look at my POM file, I'm using here the OWASP encoder. And with the OWASP encoder, I have a lot of encodings over there available. It's a very small library that can help me encode, for instance, JavaScript for HTML. So that if I want to insert JavaScript or people insert JavaScript, it escapes the characters and I do not have to do it myself with regular expressions because, well, although some people think it's fun to write regular expressions, it's always the hardest thing to debug somebody else's regular expressions, right? Or if there is somebody who likes that, please ping me today and I will send you a bunch of regular expressions to debug for me because I personally hate it. But okay, let's go to the sanitize example. Say I'm inserting a note, a comment in a website, and that comment consists of an ID for a user, the user ID, and this comment like this man is not a real superhero. Okay, so this sounds good. If it's like this, it's already fine. I mean, no weird things over here. But can you imagine that somebody inserts something like this? So instead of doing that simple string, I'm trying to actually do a script. And well, I hope everybody knows that if I do this and it will, without anything, nobody touches this, and it will be rendered on a page, it will give me an alert with 1, right? It's basic high school JavaScript. So, and again, if I don't do anything, it will be stored in my database as literally this tag. If I use this tag and output it on my website, I might have a problem because if they are allowed to do these kind of things, they may also be allowed to look if my cookies are there, what's in my session ID, etc., 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 and might forward it to some evil website. What I want to do, if people are using this create comment, I can say, okay, normally you can do this in the front end, but I would also want to make sure that it's possible from the back end. And by doing something like this, I'm using that encode library from the OWASP Foundation. And I say, for instance, encode for instance, HTML, because I want to output it straight away from this entity. And by doing this and printing this out, you will have a nice and nifty library that will make sure that the JavaScript here is escaped and is not, well, it's not harmful anymore for HTML. Look at this library and see what's useful for you, and think where you need to do this, because this is, again, a silly example, but it shows the purpose of this library. But think about it. Where should we do this? When things come into your system or things go out to your system? Or maybe both, right? Because I do not want to have corrupt data in my database, but maybe my database is also accessible from another system. So that means that database is not totally under my control. And if that part is hacked, well, we have a chain reaction. So if you use Java and we have to output HTML, for instance, or XML or whatever, use this encode library to make sure that you know that nothing horrible is happening. I mean, it might look ugly, but ugly is always better than something going wrong, right? So sanitize everything. Make sure that you know that if data is coming in, that it's checked, it's sanitized, and is escaped. And escaping is very easy, as you can see over here. Cool. XML parsers. This one is my favorite because who's using XML? Well, I can't see hands, unfortunately, right? But nobody wants to use XML. Well, although maybe the YAML hairs want to use XML nowadays. But you know that what's a problem with XML in Java? And I don't know how it's in other languages, but in Java specifically, it's external entity injections. Because by default, XML external entities, XXE, is allowed in every XML parser, which is known in Java. And I will show you what the problem is with that injection. And if you need to integrate with an older system, this might be an issue. So I have an XML parser over here. Let's get this one a bit down. And this XML parser is, again, silly, but it makes a point. It's a sucks parser. And what it does, if I feed it an XML file over here, it will just go over it. And for every start element, so the start tag, it will print it out. And if there's something in the tag, characters, so a value, it will print the characters out as well. So the start tag and the values. So let's do that. Let's show you what this parser does. Just prints it out in the console, and it prints out this file, songs by Queen XML. If I'm looking at the songs by Queen, you will see I have songs, which is a list or a collection of 2 songs in this case, both by Queen, Bohemian Rhapsody and Killer Queen from, in this case, both different albums. Fine. So far, so good. Let's run this one. As you can see over here, that it simply prints out the first tag, so the starting tag of everything, so songs, song, the artist, which could consist the value, Queen, the title, etc., 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 right? Pretty straightforward. So basically, we can do everything what we want over here if we pick out what name it is. But say I want to do something evil with this XML. This is just a simple XML parser from a factory, and I created it, and no settings, just the defaults. Now I'm taking this file. Again, it contains songs. It contains 2 songs by Queen or not. What I do here is I introduce an external entity, which is possible by default. Doc type tags are possible, and external entities can be accessed. And external entities are normally needed if your XML file needs to access other parts of the system or other files. What I'm doing here is I'm trying to access a file on my local system, say atc/passwd. And this XXC is included over here. So instead of the artist, it tries to print out the external entity, the full external entity. Let me try that. So instead of doing songs by Queen, I will do songs injection. Right? Okay. So let me run this one. What we see over here is when we run this, it will not print out just what we expected, but it will print out the whole passwd file on my local system. So if you integrate with another system using XML, by default, these external entities are available. If by default, or if somebody knows that and is able to alter that XML file with an external entity, they might be able to show stuff that is not, well, that you do not want to show the whole world. Let me get to that. Of course, you need to also make sure that your user on the system has not more rights than needed, etc., etc. But by default, the external entities are possible. And it's quite easy to solve this because it's basically making sure that the external entities are set to false, and in this case, also DTDs. So if I put in these 3 lines and I make sure that they're uncommented, yes. And what I do over here, you see both on the factory and on the parser, I will say that external general entities are not allowed. And just to be sure, I make sure that doc type inclusions are also not allowed, because you can do this in multiple ways, but this is just one. And by doing these 3 things, and you can set this on basically every XML parser that holds the standard, maybe in a different way, but these are the things you can set. You are not vulnerable for these attacks anymore, because if I run this again with these flags on, you will see that artists, which normally shows the XXE or the external entity, will not print anything anymore because external entities are not allowed. So just be aware that external entities by default, without doing any settings on it, and you are introducing stuff from other people's system, you might have a vulnerability. Cool. Java serialization. All right, it is the gift that keeps on giving, as they say, right? Hopefully nobody's using Java serialization. Well, we already know it has some problems, right? Because what does serialization do? We have an object and we translate that object into a byte stream. And that byte stream we want to store somewhere, on a file, in a database, or whatever. We want to make it outside of the system and store it over there. And I'm talking here about Java native serialization, not about marshalling, unmarshalling from JSON libraries or JSON libraries or whatever. Then we have deserialization, which is basically the other way around. We have the byte stream, and we want that byte stream. We get it out of that database or out of that file and we want to transfer that back into an object, which seems legit. We can also send it over the network or whatever. Well, if we have if you want to deserialize, the problem is in this part, because deserialization already has, well, deserialization uses a lot of reflection, and reading the object before it knows what kind of object it is, you already might be in trouble with that. And that's kind of vague, right? But it reads the object first before it casts it to a node in this case. That's one of the issues. Also, another issue is, well, let me get it to this point. This is not my example. I stole this example, and I will credit the person who wrote this. Say we have this data holder. We want to deserialize. And as you can see over here, data holder contains data, which you say, okay, we should have a reference to data, right? Well, that is kind of right, but not totally, because it needs to, when deserializing, it reuses references that are already used in the chain. So if in some way in the chain of deserialization, there's already something that is a date is deserialized, it will use that same reference again. So that means if I have a class in that, in my deserialization chain that extends date and does something completely different, I have no clue what the data holder can do anymore, because it reuses references. That's the way serialization works. And there's a lot of things wrong with serialization, but it's already old, right? So don't hate it on this. If you want to know more about the problems in serialization itself, I would suggest to go to this video by Brian Getz and Stuart Marks. This one is from DevOps Belgium last year, and I think it's a good introduction in what the total package of problems is with deserialization. But what if you need to implement serializable, right? If you need to implement it because, well, that's the domain I inherit. Well, basically what we can do is make sure that we are able to, well, I would say don't do it. That's the first one. Don't try to avoid these kind of things, and try to make sure that deserialization is not, or serialization is not possible. If you need to do it, well, you might have a, and now I'm looking for the demo because I had, yes. And this is not the good demo. Oh, I got it. Well, the point is, say I want to serialize an entity I have here, this node entity. What I can do is I can implement this private method read object, and I can throw an exception. If I throw it as exception, it's although it's a private method, because deserialization is using a lot of reflection, we can make sure that it throws an exception right away and it doesn't go any further. So by doing this is one of the things you can use by implementing this private method read object if it's a serializable object, and make sure that it throws an exception. You're not allowed to deserialize it. So if there's something wrong in that chain, you prevent it. And you might think like, yeah, what the hell? There is nothing wrong in my chain. But you know how many classes are there on the class pad already on your system? We already showed you how many files there are, or how many lines of code there were. So there might be a file possibly there that might have a problem or might execute code when it is created. So if you prevent serialization by default, you will not have that issue. Also, this problem also comes more or less up when you do marshalling and unmarshalling with libraries, but that's a whole nother story. And you just have to make sure that if you use a separate library, that it's not vulnerable for deserialization issues. Due to time, I go into the next one. I have, well, 7 minutes left, and I will go to encryption and hashing. Well, we need to make sure that we do encryption and hashing, right? But first of all, don't write your own. There are still people that are convinced that they can write their own encryption algorithms. unless you are a cryptographer or a crypto analyst or whatever his name, whatever such a title is, don't do it. Look at what is the current standard, and what is the current standard used by high-profile companies and things like government agencies, and use that. Because doing it yourself, you might be in trouble, and, well, all these other things are licensed, more or less. So what we can do ourselves, we can use Java low-level encryption capabilities, which is perfectly fine. There are a lot of capabilities. Or I don't want to get into that because, well, it's a lot of boilerplate code. So I am using strong vetted libraries for encryption. There are a lot of libraries available that are there. The point is that we have to make sure that these libraries are safe. And what's safe now cannot be safe today, or can be vulnerable tomorrow. So we need to recur that chain of thought that if we still need to use that library, not just once, but every single time. Let's look at two different ways of encryption. Well, we have simply just cut it in very simple terms. We've got two-way encryption. For instance, for credit cards, we want to encrypt this into a string, which is not breakable, but we also need to make sure that we can get that credit card number back, right? Because we need to use it. That's two-way encryption. And, well, most years, we also need some sort of one-way encryption, hashing. For instance, we have a password. We do not want to store the password itself. We want to store the hash. And if a password is the same as the password it was before, then it gives you the same hash. If it's a different password, it will give you a completely different hash, even if it's just password 2 or password 3 or password 4. That's one of the things that a good cryptographic hash needs to be, and that's the point. Not just use a hash, use a strong cryptographic hashing algorithm. Because normal hashes can be fast. And we want cryptographic hashes to be strong and kind of slow because we do not want to get broken, right? So if we're using a hash, it basically always has the same length. It has the same input will give you the same output. And, well, you basically lose data. So you cannot go back from the hash to the original password. Just try in every system that you need to put a password in. If you can recover your password and it shows you your exact password back, then it's not using a strong cryptographic hash. It's not using a hash in general. So check that. So for the first one, right, for the two-way encryption, I'm using Google Think. And Google Think I'm using in this case the Advanced Encryption Standard, AES, which is one of the, well, advanced encryption standards. There are more and there are higher levels, but look at the level that is applicable to your context and make sure that you're not doing it yourself, but use a library that does it. And using that library is something like this. I have to configure it once, and then I can basically use encrypt, which gives me a byte array, or decrypt, which can decrypt that byte array. And by using that and specifying which kind of algorithm I'm using, and this is AES, and AES, I'm using authentication encryption with associated data. Well, look it up what you think of it. The associated data is not by default. It is needed, but not by default encrypted. But anyway, use these libraries that are strongly used and will be updated, and you make sure that you use the latest version of these updates so that your encryption is and stays strong. If you need to use something for password encryption, and I have to hurry because I have 2 minutes left, make sure that you are simply using Spring Security, because Spring Security has something like bcrypt password encoder. And for this point, bcrypt is still one of the strongest ones. So by just using Spring Security and using the bcrypt encoder, you can use bcrypt to encode your passwords and match the encoding passwords towards your cryptographic hash. It also has automated salts and that kind of stuff built in, so you do not have to care about that. Last one, logging. And it sounds weird, but logging is the most important part of all, because it's not if you get hacked, it's probably when. And this will be the questions you will get into your face. Although the solution might be easy, people will be saying afterwards, like, okay, how long was this in? Well, we can see that. But who was exposed? How long was it there? If you do not have proper logging and maybe active alerting on it, you might be a victim for ages. or you cannot even backtrack if you are actually caught, if somebody found out this problem, right? So make sure you have sufficient logging and you log everything. Make sure that you have centralized logging and active alerting. For instance, use the Elastic Stack on that and log on high CPU, log flat lines, an overmat on 400, the number of an insane amount of requests, etc., etc. So you can make sure that you respond in time. And this one is very important for the aftermath after. If something goes wrong, so you actually know what happened and how awful it was, because you probably need to report this to the outside world. If you want to know more, I would suggest you go to this cheat sheet, which has the 10 security best practices all online. And that's my talk for today. The slides will be published, and I will publish that cheat sheet also, so don't worry about that. That's it for now.
Thank you very much, Brian. And
right.
I want to say that the talk will be available starting tomorrow in the Generation channel on YouTube.
Okay.
So let's see if we have questions for you. Actually, we have a question on Slack. Regarding cross-site scripting, do you think the sanitizing should be made on the server side, on the client side, or both?
Both.
If both, can that cause any messy things like the ones you showed in the log?
Sure, it can cause messy things. Yes, it can. But I'm talking now from a security perspective. So I would say both, because if something comes in, it depends on how your context of your system is. But if something comes in, you do it on forehand, so you see what the problem is, and you can validate it. Not just encode it, but also you can validate it. If you see there are weird characters in it, maybe you shouldn't even allow it in your system, right? The other way around, if it comes out of your system, if it comes out of your database and you show it on your website, on your web front end or on your app, who knows who's there already in the database? If it's a shared database, or for instance other parts of the system are compromised, you do not want it to be like a virus that spreads, right? You just want to contain it in the place where it is. So I would suggest, from a security perspective, I would suggest both, and make sure that you have proper validation on your entities that you put to your database to make sure that you have valid stuff in there.
Mm-hmm. Thank you. Let's see if we have another question. We don't, but I have a comment for you, Brian. I see that a lot of stuff that you have presented actually relates with the top 10 from OWASP, right?
Yeah, it relates a lot to the top 10. Exactly.
Yes. So, as a suggestion, if I may, everyone should look at the OWASP project, because there is also very good insight there to everyone, for web applications, for mobile applications, for lots of good stuff there.
Definitely. Why I did this talk is because to plan it specifically to Java, and to see that all these things that are there in the OWASP top 10 are also in Java. It's not language agnostic. It is. We have the same problems if you do not look closely, and we need to make sure that.
And you have specific issues just with Java, like for example, the serialization. I think that one applies to Java only.
Yeah, the serialization applies to core Java only. Exactly.
Yeah. Okay, so just a quick lookup. Okay, isn't script prefer over bcrypt?
Depends. Bcrypt and script are scripts. It depends on who you talk to. You can specifically both use script or bcrypt. Some say that script is not developed for password encryption. Some say it is, and I am not a cryptographer, so you can, in my opinion, bcrypt and script are both strong algorithms. But keep tracking this. If you think that script is stronger and you have proof for that, please call back at me, and I'm changing it in my slide deck. But you you need to keep doing this. You need to keep checking this, because maybe tomorrow bcrypt is not interesting anymore, right?
Yes.
It can happen.
The things are changing all the time, right? And if I remember correctly, the last time I checked it, I think now the recommended one is Argon 2 actually for passwords.
Yeah, Argon 2. I don't know if there's already a good implementation for Java. If you can have an Argon 2 data.
I think you have it on Bouncy Castle, if I am not mistaken.
Yeah, could be. But then you need to insert Bouncy Castle again. If you just want to be, it depends also on the level of how secure you need to be for your application. If it's just a simple endpoint with some data you need to have, bcrypt can be fine. But if it needs to be high end, I get it.
Okay, we don't have any other question. So, Brian, thank you very much for your time, and thank you for being with us.
Thank you so much for having me, and thanking the crew on the back end that does the job. Thank you so much. See you later.
Okay, I just want to say that this was my last talk presenting. It will be Tiago, my friend, that will be presenting the next track. So thank you all.
See you later.
See you in a few minutes. Bye.
Bye.